Now let's derive an expression for the velocity of a wave. Suppose let this be our x-axis and this be our y-axis. Suppose there is a wave traveling in the positive x direction like this. Let at time t is equal to, let's say t equal to t, the wave is in this form or in this position. After some time, let's say t is equal to some t plus delta t. Let's call this as t1 and this time as t2. After a time t plus delta t. Now the wave is at a new position like this. Because the wave has traveled, move forward, or it just travel horizontally along the x direction. Now if you take any point, let's take a point P in here, and this P has now reached a new point P dash. Clear, this P has moved. But remember, this displacement and this vertical displacement remains the same. We can call y1 equal to y2. We have y1 is equal to y2. Since the height of the point, since they both represent the same point, the height remains the same. That is y1 equal to y2. But you know the displacement relation y of xt, or simply you can write y equal to a sine omega t minus kx. This is the displacement relation of a progressive wave. We already have derived the expression or the derivation for this. You can always go and check the video. I'll put the link in the description below. Which means both the cases the wave remains the same. So amplitude remains the same. So now for y1 you can write a sine omega. Let's take this point P is at a horizontal distance of x1 from the y-axis or from the origin, and this point P dash is at a distance of x2 from the origin. So this omega, then t will be initial time t minus k into this distance is actually x1 is equal to, then for y2 a sine omega, the time is actually t plus delta t minus k, x is actually the displacement is x2. Clear, you can cancel this one and this one. Sine of this equal to sine of this means omega t minus k x1 is equal to omega times t plus delta t minus k x2. Clear, so omega t minus k x1 is equal to omega t plus omega delta t minus k x2. You can cancel this one if you take this to the left. So k x2 minus k x1 is equal to omega delta t, implies k into x2 minus x1 is equal to omega delta t, implies, now if you see x2 minus x1 is this horizontal displacement, that is actually delta x, where we have delta x is equal to x2 minus x1. This x2 minus x1 is delta x. So k delta x is equal to omega delta t, or you can write delta x by delta t is equal to omega divided by k. What actually is this delta x by delta t? The horizontal displacement divided by time, which represents the velocity of the wave, v. So v equal to omega by k. So this is the expression for the wave velocity. Now you can simplify this. V equal to omega is actually 2 pi by t time period. K is equal to 2 pi by lambda. Wave number, k represents the wave number. 2 pi will get cancelled. This is equal to lambda divided by t, or v is equal to lambda into 1 by t. You can write this as this expression in the form 1 by t. So this is equal to what is 1 by time period? Reciprocal of time period. It's actually frequency. So velocity will be lambda times frequency. So this is the wave velocity. Lambda f is the frequency. Lambda means the wavelength. Okay.